You can see we get we get a peak right here. And so right now we're not sure whether air is made up of one substance or two. If you only see this one peak, then air is made up of that one substance. As we continue to watch it, we see a second peak develop. And that second peak tells us that air is at least two substances. It may be more than two substances, depending on the sensitivity of our detector and what exactly our column is made up of. This particular column, it turns out, absorbs certain gases like carbon dioxide, but it lets nitrogen and oxygen pass right through. This peak is the oxygen. This peak is the nitrogen. And so air is a mixture, a homogeneous mixture of two different substances, nitrogen and oxygen. I'll go ahead and print these off for you. Before I print them off, I'm going to have the computer determine how big the peak is, because how big the peak is tells us roughly how many of each kind of molecule is present. So I've highlighted it, and it's calculated an area, literally 1/2 base height, because it's pretty much a triangle. And we'll do that over here. Now those two areas, if we add them together, I'm just going to round them off here, it works out to an area of about 2,600 units. I can take each of the individual areas and divide by that 2,600 to tell me what percent of the molecules are one kind versus another. So if I take 500 divided by 2,600, it works out to about 1/5, or about 20%. If I take 2,100 divided by 2,500, that works out to about 75%. So air is about 25% oxygen, 75% nitrogen. Now what we're going to do is try an experiment where we see if we can alter that. And so let me print this out for you. Yeah. So what I'm going to do, and normally I'd have you guys do it, but we're videotaping here. I don't want to put you in a bind. What I'm going to do is I'm actually going to breathe my own air for about 10 respirations and see if that affects the relative proportions of nitrogen and oxygen. Alright, so I'm going to sample this air, use this needle, and believe it or not, if I put it through the thick part of the balloon, it doesn't pop. I'm going to pull out a 1/2 milliliter sample, just like before. So now all those molecules have pushed their way in. Got a sample right here. Or we go to the injection port. And off we go. Now we should see peaks show up at about the same time, and that's because the same molecule with the same gas chromatography setup should take the same amount of time to get to the end of the column. If we change something, either how fast the helium is pushing or the kind of material in the column, all bets are off. The molecule is going to behave differently. So that's our oxygen peak. Now it is a little bit different in terms of timing, and that's because there's this manual bit where I have to come over and start the collection, but it should be around 50 seconds under these conditions for the oxygen, and it should be around 100 seconds for the nitrogen. And there's our nitrogen peak. and they're the respective areas. And so one of the questions you have to answer in the lab report is, did we change the relative proportion of the two peaks? Are they still roughly 25%, 75%?